Good morning, students. So, in the last class, we have started about biomolecules. So, we have discussed what are biomolecules, right? So, we have seen what is biochemistry, right? Then we have started with our first biomolecule, that is carbohydrates. Then we have seen the classification of carbohydrates, right? So different classification we have seen. Then we have also seen about what are reducing sugars, what are non-reducing sugars, right? We have studied about what are sugars, what are non-sugars, right? Then today we are going to start with the structure of glucose, right? We are going to start with the structure of glucose. We've also discussed about what are animals, what are animals, right? So we are going to start with the structure of glucose. So glucose, okay. Glucose is a monosaccharide. So it is a monosaccharide with the general molecular formula as C6H12O6. Okay. So what is the molecular formula of glucose? It is C6H12O6. Fine. So it is a monosaccharide. Monosaccharide means it consists of only a single unit of sugar. Okay, it consists of single unit of sugar. Mono, right? We have seen this. What is monosaccharide? So glucose is also called as the other name of glucose is grape sugar. Okay, what is the other name of glucose? It is grape sugar. Okay, so it is the other name of glucose is grape sugar. Okay, grape sugar. Fine. So the other name of glucose is grape sugar. Fine. So, where this glucose is present? So, this glucose is present in, it is dextrose. Okay, it is a dextrose which is present in sweet fruits and okay, it is a dextrose which is present in sweet fruits and in honey. So, next we are going to see with the preparation. Okay, how we prepare glucose. So next we are going to see how we are going to prepare glucose. So the first preparation is from sucrose. What is sucrose? Sucrose is a cane sugar. Okay, sucrose is a cane sugar. So we are going to prepare our glucose from what? We are going to prepare our glucose from cane sugar. Okay, that is sucrose. So sucrose, okay. So sucrose, what is the formula of sucrose? C12H22O11. Okay, C12H22O11. When it undergoes hydrolysis, hydrolysis means what? When it reacts with water. Okay, when it reacts with water in the presence of concentrated HCl. Okay, in the presence of concentrated HCl, that is you can take a acid whether sorry, not concentrated, you can take dilute HCl or H2SO4. Okay, you can take either you can take a dilute hydrochloric acid or you can take a dilute sulfuric acid. In what medium? It should be taken in alcoholic medium. Okay, it should be taken in alcoholic medium. It should be taken in alcoholic medium, which further gives you glucose and fructose. Okay, which further gives you glucose and fructose. So, what is the first preparation? We are going to prepare our grape sugar, that is glucose. From what? We are going to prepare it from cane sugar. So that is sucrose. So sucrose, what is the formula? C12H22O11. When it reacts with water, that is when it undergoes acid hydrolysis. Why acid hydrolysis? Because it is reacting in the presence of acid. Okay, so it is undergoing acid hydrolysis to give you in an alcoholic medium to give you glucose and fructose. So please remember the reaction. Okay, reaction is very important. So sucrose undergoes acid hydrolysis to give you glucose and fructose. Okay, so the next is from fructose, from starch. Okay, that is from starch. So next is from starch. What is starch? So commercially, so this is a commercial preparation. Commercially means what? For a large scale. Okay, commercially we can prepare this. That is at a large scale. Okay, industrially. So commercially, glucose can be obtained by hydrolysis of starch. Okay, what is starch? C6H10O5. Okay, C6H10O5. So we can obtain glucose by hydrolysis of starch, okay, with dilute acids, okay, with the dilute acids. So this also undergoes a acid hydrolysis. Okay, it undergoes acid hydrolysis at 393 Kelvin. Okay, it undergoes acid hydrolysis. So on the arrow you need to write H plus and 393 Kelvin under pressure. Okay, under a pressure of 2.3 atmospheric pressure. So these are the reaction conditions. So commercially you can prepare glucose at a large scale by undergoing acid hydrolysis of starch. So starch is undergoing acid hydrolysis and you obtain what? And you obtain glucose. Okay, you obtain glucose. Fine. So this is the preparation. So this is the two important preparations of glucose. So this is the structure. Okay, this is a Fischer structure. So this is a structure of glucose. So this is a structure of glucose. Okay. So so this is a Fischer structure, that is plus glucose. It has D configuration. What do you mean by D configuration? When the OH is on the right hand side. When the OH is on the right hand side, then it is called as D configuration. Okay. So when the OH is on the right hand side, then it is called as D configuration. Okay, that is D plus glucose. Okay, D plus glucose. D means what here? D means the OH group on the first chiral carbon. This is the first chiral carbon, right? That is the OH group on the first chiral carbon from the bottom. Okay, we have to see the bottom, not the top one. So we have to see the bottom. So from the bottom is on the right hand side, and plus means it is dextro-rotatory. That is, the plus means what? It is a dextro-rotatory. That is, it is turning the plane polarized right. That is PPL. It is rotating the plane polarized light towards the right side. Okay, when it is rotating the plane polarized light towards the right side, that means, so it is indicated by the plus sign. And OH means what? That is D means what? That is the OH from the bottom. Okay, the first chiral carbon from the bottom is on the right hand side. So this is the structure of glucose. Okay, so this is the structure of glucose. So next important reaction. So next we are going to see the structure elucidation of glucose. Okay, we are going to see the structure elucidation. So structure elucidation of glucose. Okay, so we are going to see the structure elucidation, how the structure of glucose. Okay, so there are certain evidences which provides the open chain structure of glucose. Okay, so from elemental analysis, so the first point is what? From elemental analysis and from the molecular mass. Okay, when you determine the molecular mass, the molecular formula of glucose is 6H12O6. So how do you get obtain this formula? That is by elemental analysis. Okay, which elements are present? Okay, after doing the analysis, which elements are present, right? And by obtaining the molecular mass. Okay, so by measuring, by determining the molecular mass, we can obtain the molecular formula, that is C6H12O6. Okay, C6H12O6. So this is the what you can say, this is a elucidation, this is a formula, molecular formula of glucose. The second is, how do you confirm for the presence of six carbon atoms, right? How do you confirm? How do you confirm that? Yes, how do you confirm that? See, I'll write the structure here. So I'll write the structure here. Okay, the open structure H double bond O C O H. Okay, so this is the open structure of glucose, right? So this is the open structure of glucose, right? So CH2 OH. So I'll write it closer. CH2 OH. So how many carbon atoms? Just count here. So here, one, two, three, four, five, and six. So how do you count for the six carbon atom? In a straight chain, right? These carbon atoms are in a straight chain. So how do you confirm the presence of the six carbon atoms in a straight chain? That is glucose when it is undergoing heating. Okay, when you heat glucose, so this is the first reaction. When you heat glucose, so this is a structure of glucose. So when you heat the glucose, okay, with HI, what is HI? Hydrogen iodide. Okay, with hydrogen iodide. So when you heat the what glucose with hydrogen iodide, it forms what? It forms N-hexane. It forms N-hexane. Okay, so which indicates that the six carbon atoms are linked in a straight chain. N-hexane means what? With the straight chain, that is here CH3, CH2, 4, CH3. So you can count the number of carbon atoms: 4, 5, 6, right? So this indicates that in a straight chain, six carbon atoms are present. Okay. So when you heat, so this confirms that in a structure of glucose, there are six carbon atoms which are present in a straight chain. Okay. So when you heat your glucose in the presence of hydrogen iodide, this gives you N-hexane. So these reactions are very important. Okay. Then next one is what? The presence of. So next we'll see the presence of your carbonyl group. Okay, the presence of this carbonyl group. Fine. So how this indicates the carbonyl group? This is a carbonyl group. C double bond O is a carbonyl group. So how do you confirm the presence of carbonyl group? So glucose. Now again, this is the second reaction. So glucose when it reacts with, okay. So this is the second reaction. So glucose when it reacts with hydroxyl amine. So what is hydroxyl amine? Hydroxyl amine is uh, NH2OH. Okay, that is NH2OH. It is hydroxyl amine. Okay, so this is a hydroxylamine. So when you treat your glucose with hydroxylamine, it forms a oxime. Okay, it forms a oxime. Fine, forms a oxime, and okay, so this confirms that your what is present. You can see. So the reaction only takes place at the carbonyl carbon. So this indicates the presence of carbonyl group. What it indicates? It indicates the presence of carbonyl group. So when you react it with hydroxylamine at your carbonyl carbon, okay, at your carbonyl group, what is formed? Oxime. That is glucose oxime is formed. So this is a structure elucidation. So we are seeing how the this indicates the presence of carbonyl group. I hope this is clear. Okay. So the third one is what? Next, we are going to see that what type of carbonyl group it is. Okay, that is, it is a aldehyde group, right? It is a aldehyde group. So next we are going to see the presence of aldehyde group. Okay, next we are going to see the presence of aldehydic group, that is glucose. Okay, it undergoes oxidation. Oxidation means what? Addition of oxygen. So glucose, it undergoes oxidation with bromine water. You can see this bromine water. So bromine water is a good oxidizing agent. Okay, so when glucose it is reacted or it is treated with the bromine water, it gives you gluconic acid. Okay, gluconic acid. So you can see at this carbonyl carbon, right? There is a addition of what is your aldehyde group? It is CHO. So what is extra here? Your one at there is addition of one oxygen atom, right? So it is forming a gluconic acid. What is the formula of acid? COOH, right? So it is forming what? Gluconic acid. So there is an addition of oxygen atom. So this is forming a gluconic acid. So this confirms the presence of your what aldehydic carbonyl group. Okay, the carbonyl group is present, but in carbonyl group either it will be a ketone, okay, or it will be a what do you say, right? So either it will be a ketone or it will be a aldehyde group. So so in our structure there is presence of what? Aldehyde group. So this confirms that there is a aldehyde group. So glucose, when it undergoes oxidation with bromine water, it gives gluconic acid, which is having six carbon atoms. Right? Again, the carbon atoms are remaining the same. There are six carbon atoms. This indicates that the carbonyl group is aldehyde group. Okay, this indicates what? That the carbonyl group is a aldehyde group. Fine. So this is our this is our third test. Okay, this is our third test. So next we are going to see is the presence of next we are going to see is the presence of your alcoholic group. Primary alcohol is present, right? Your primary alcohol is present at the bottom. Can you see it? Right? So in our structure, what is present here? Primary alcohol is present, right? So how do we determine the presence of this primary alcoholic group? Okay. So next reaction is it is the presence of primary group. Okay, the presence of primary alcoholic group. So when glucose, okay, the fourth reaction is here. So when glucose is undergoing oxidation, okay, this is a strong oxidizing agent. So when glucose is undergoing oxidation, so HNO3, that is nitric acid, it is a strong oxidizing agent. So when it undergoes oxidation, okay, nitric acid, the glucose as well as gluconic acid, it gives you the dicarboxylic acid. Okay, that is your OH group. Okay, both the CHO, that is aldehyde group, and your alcoholic group, that is CH2OH, both are converted into acids. Okay, it is converted into acid because nitric acid is a strong oxidizing agent. So you can see here, right? You can see here. So on oxidation with nitric acid, glucose, okay, that is the gluconic acid which was formed in the above reaction, that is COOH. Okay, it forms it gives you a dicarboxylic acid, that is the acid name is saccharic acid. Okay, so this indicates the presence of one primary alcoholic group. Okay, this indicates the presence of primary alcoholic group. Fine. So this is the next reaction. Fine. So this indicates that in our structure, what is present? Primary alcoholic group is present. So next structures we are next this what next reaction is what we are seeing the presence of this, okay, five OH group, one, two, three, four, and five, right? You can see here in the structure. The now we are going to confirm the presence of five OH groups, right? One, two, OH groups, right? Five OH groups, okay. Acylation, okay, acylation of glucose with acetic anhydride, okay, that is acylation of glucose with acetic anhydride. It gives you what? See here, the fifth reaction is here, okay. So acylation, so you can see, I'll just stop it. Okay, acetylation, sorry, not acylation. Wait, just a second. Hmm. Okay, so this is a acetyl group. So acetylation of this glucose, okay, with acetic anhydride. So it is undergoing acylation. So the reaction is acylation, but this molecule which we are going to react, it is a acetic anhydride. So when it is undergoing a acylation reaction, that is when this glucose, okay, when this glucose is treated, okay, when this glucose is treated with acetic anhydride, it gives you a glucopentacetate. It is giving you a glucose pentaacetate. This confirms the presence of what? This confirms the presence of 5-OH group. Means what it is resulting? Wherever the OH group is there, okay, wherever the OH group is there, this group is going to attach to CH, O, C double bond O, CH3. Okay, this what you can say, this bond is going to break, and everywhere you are going to get this structure. Okay, I'll just draw here. So it will be O C double bond O CH3. Okay, same here also. O C double bond O CH3. Okay, then O C double bond O CH3. 1, 2, 3, 4 CH2. Okay, then O C double bond O CH3. Fine. So like this is the structure of your glucose pentaacetate. Why penta? Because there are 5-OH group. Okay. So this confirms that there are presence of 5-OH group. Okay. And the molecule is stable because the OH groups are present on different carbon atoms, right? The OH groups are present on different carbon atoms. So this confirms the presence of OH group. I hope this is clear, right? So based on this all above facts, right? So we have seen how many? One, two, three, four, five, six tests. Okay, so based on the sixth above reactions of glucose, okay, these are the open facts. Okay, so the open chain of what is that? Glucose. Okay, the open chain of glucose is what is the structure of glucose, right? I'll draw this. So this confirms that the open chain of glucose. Okay, the structure of glucose from the above structure is this OH, okay, OH, 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 and CH2 OH, okay. So this is the open chain structure. So this is the open chain structure of glucose. Okay, this is the open chain structure of glucose. So from the all above facts, this is the structure of glucose. I hope this is clear. So this was the structure elucidation of glucose. So there were some objections which were against the open chain structure of glucose. So what are the objections which are against the open chain structure of glucose? The open chain structure was unable to explain the following reactions. So there were some reactions which could not be explained by the open chain structure of this glucose. Okay, so that is it could not, the open chain structure, it could not give the 2,4-DMP test, that is dinitrophenol test. Okay, 2,4-dinitrophenol phenyl test. So it could not give the skiff test. Okay, and it does not form the hydrogen sulfide product, that is a addition product with NaHSO3. So these were the limitation. So that is the open chain structure of glucose could not react. Okay, could not react with the DMP test. That is, it could not give with DNP test. Okay, So 2,4-DMP test, Skiff test means what? It should give you a pink color. So it could not give a pink color with Skiff reagent, and it does not form a addition product with this hydrogen sulfide. Okay. So this was the first limitation you can say. Okay. Then pentaacetate of glucose. Okay, the pentaacetates, we just saw the pentaacetates of glucose. It does not react with the hydroxyl amine, that is NH2OH. So this pentaacetate, it does not react with hydroxyl amine, that indicating the absence of free OH group. That is free aldehydic group. Okay, so the pentaacetate of glucose, okay, it could not react with the hydroxyl amine. So this indicates that the absence of free aldehydic group. The aldehydic group which is present, it is not free. Okay, then next structure was glucose. It could exist, okay, in two crystalline forms, that is alpha and beta forms. So as the when the glucose was made to react with hydroxylamine, okay, that is pentacetate. When the pentacetate of glucose was reacted with hydroxylamine, could not give the reaction because it could confirm that the aldehyde group which is present that time with pentacetate of glucose, it is not free. Okay, so the next conclusion was that the glucose, it was existing in two crystalline forms, that is alpha and beta glucose, and these alpha and beta forms are called as what? It is called as the anomers. Okay, it is called as the anomers. So they differ in what? They differ in the optical rotation. So they differ in the optical rotation, and they also differ in the melting point. So these are the objections which were against the open chain structure. So this so there's a cyclic hemiacetyl. Okay. So there's a cyclic hemiacetyl structure is proposed for the glucose, in which the OH group from the fifth carbon atom. Okay. So, because of this objections, a cyclic hemiacetyl structure is proposed for the glucose, okay, in which the OH group of the fifth carbon atom will be added to what? It will be added to the CHO group, and it forms a sixth membered ring. It forms a sixth membered ring which will exist as, okay, so we'll write the structure of first glucose. So this is a glucose structure, so important. So practice the structure of glucose. So you have to write it as many times. Okay. So OH 6 OH H 6 OH CH. So what did I say? The fifth carbon. Okay. So if I calculate this, so 1, 2, 3, 4, 5 and the 6. So the fifth carbon, okay, from this fifth to this aldehyde group, the first one, okay, how the hemiacetals are formed, just see. Okay, so we'll draw the structure. So it will be, so from the fifth carbon, so from this fifth joint, okay, and this is your so H, okay, this is your OH, then H, OH, C, OH, H, C, H, OH, C, H, CH2, OH. So from this fifth carbon, okay, and to the first carbon like this. So this the joining takes place. Okay. So here the OH will be there. Just a second. Hmm, understood? So this is the alpha D plus glucose. Okay, this is alpha D plus glucose. Okay, now we'll write the beta D structure. So beta D plus glucose structure. How it will be? How will be the difference? Only difference will be OH group. Okay, CH. Then this will be CH OH. This will be CHO H CH OH CH H2OH. Okay, then I hope this is clear. Okay, so these are the hemiacetal structure and it gives rise to five-membered ring, right? You can see here, this is a five-membered ring, right? One, two, three, four, and five. So the joint is from first to fifth. So this forms a five-membered ring. So this cyclic hemiacetal structure, okay, it was proposed. So this two cyclic forms of glucose, okay, these are the two cyclic forms of glucose, and they differ only in the configuration at C1 carbon, right? You can see the changes only. You can see the changes only at the C1 carbon, right? So this is a C1 carbon. The change is only at the C1 carbon. Okay. So as if there is a change in only C1 carbon, then it is called as what? It is called as anomeric carbon. Okay. Such isomers that is alpha and D form are called as what? They are called as the anomers. They are called as the anomer. So when there is change is only at the C1 carbon, so this alpha and beta forms of glucose are called as the anomers. And this cyclic structure of glucose is best represented by Hayward structure. So next we are going to study about the Hayward structure. So this cyclic representation. So these are the hemiacetal structures. Okay, these are the cyclic hemiacetal structure. So these cyclic hemiacetal structures can be most what you can say nicely, or it can be very nicely represented by Hayward's structure. So we'll see now the Hayward structure. I hope this is clear, right? So we'll go for the Hayward structure. Okay, so this is the Hayward structure. So we are going to see the Hayward structure of glucose. So Hayward, what is Hayward? Before going to the Hayward structure of this, so the Hayward projection is a common way of writing a structural formula of sugars. Okay, this is a common way. So this is a way of writing the structural formula in case of sugars, that is your monosaccharides and disaccharides, with an unpretentious three-dimensional perspective. So, this is a way of writing the structural formula of sugars with the three-dimensional point. Okay, so this type of illustration is mostly used in organic chemistry, especially in your biochemistry. Okay, especially in your biochemistry, this type of structures illustration is done. Okay, so this is the you can see the above. So this is a structure elucidation of what? This is a structure that is your Hayward structure of your glucose. So here you can see, okay, so this is a five-membered ring. So this is one, two, three, four, and fifth carbon, right? And your OH is at the right hand side, right? The thing which I had written just before, okay, that is your cyclic hemiacetal structure, and the OH on the right hand side. The same thing, only we have put up in a ring form. Okay, so that was also a five-membered ring only, but here we have just made it in a ring form. Okay, now here the OH is on the right hand side. So this is called as alpha D gluco. Okay, and it is a pyranose structure. Pyranose means what? It is a five-membered ring, so it is called as a pyranose structure. And here you can see one, two, three, four, and five. The OH is on the left hand side, so it is a beta D plus glucopyranose. Okay, it is alpha beta D glucopyranose. Okay, so this is the structure of your that is Hayward projection structure of your glucose. Okay, so glucose, it will be in pyranose structure. Okay, here the below one which is given. So these are two, okay, here you can see that there are two, what you can say, glucose. These are two glucose structures. These two glucose structure, it is joined, okay. That is a C1. This is a C1 of carbon, and this is C1, C2, C3, and C4 of the other carbon. Okay, so C1 of one glucose is linked to the C4 of the other glucose unit, okay. And this is a maltose. This is the structure of maltose. Okay, this is the structure of maltose. So it is a reducing sugar. So this is also a reducing sugar because a free aldehyde group can be produced at your C1 of second unit of glucose in solution. So C1 of second unit of solution, your free aldehyde group can produce. So such linkage, okay, that is just now we saw. So that is the linkage which is between the two monosaccharide units. Just now which we saw, right? Here, this linkage, okay, that is between the two monosaccharide units. So these are two separate units. This is a one structure of glucose. This is another structure of glucose. So when the linkage is present between two glucose units, they are called as what? It is called as the glucosidic linkage. It is called as glycosidic linkage. So there's linkage which is between the two monosaccharide units through the oxygen, right? Through the oxygen, it is called as glycosidic linkage. Okay. I hope this is clear. Yes. So now we'll see the structures. Okay. We'll just see the structures of fructose. Okay. I'll just go on writing the structure of fructose and the other thing. So next is our fructose. So this completes our glucose. So next is fructose. What is the formula? It is C6H12O6. Okay, C6H12O6. So this is known as ketohexose. So this is example of ketohexose. Okay, as what is glucose? Glucose is a aldohexose. Okay, because there is a aldehyde group. In fructose, there is a keto group. So it is a ketohexose. So how it is obtained? It is obtained by hydrolysis of sucrose. Okay, it is obtained by hydrolysis of sucrose. It is obtained by hydrolysis of sucrose. So this is levorotatory. Okay, this is levorotatory means what? What do you say? It will rotate the plane polarized light to left hand side. Okay, and it belongs to D series. It belongs to D series. Why D series? Means the OH group is on the right hand side. So levorotatory means it will be minus. Okay, so that is it is rotating the plane polarized light to left hand side. Okay, left. Okay, it exists in cyclic form, which are obtained by addition of OH from the fifth carbon to the keto group, and thus it forms a five-membered ring. So I'll write the structure first. So before that, I'll write the structure of your CH2OH. Okay, then C double bond O, C H O H, C H O H, C H O H, then CH2OH. So this is our structure of our what fructose. So what is the name? D minus, okay, fructose. This is the structure of D minus fructose. Fine. So this here 1, 2, 3, 4, 5, and 6. So this is our structure of glucose. Okay. So now we'll so the uh, cyclic structure, how it is obtained from the fifth carbon to our first carbon. So I'll write it now. So how I'll write it? So C. Okay, and then this will be CH2OH. Why? because your OH will be on right hand side in the first structure. So if the attack is taking place, okay, so if the attack is taking place from this, okay, okay, like this, then it is forming your what? It is forming CH2OH. Then the second structure will be C, okay, one side. Just a second, sorry. Okay, the attack will be not on here. The attack, if it is taking place from here, okay. So that if I attack it from here, okay. If I attack it on the keto group, so the attack will take place at this carbon, okay. That is from the OH group to the keto group, okay. So just see the attack. Okay, so how it will be? I'll write the structure now. So C, so this will come here. So to this carbon C, okay, this carbon C, CH2OH will fall on the left hand side, so COH. Then this will be the second carbon, that is COH. Okay, here I'm writing the structure COH, H, then CHOH. Okay, then comes our third structure, that is CH, and here this will be your OH, so this will be O and like this, okay. And here comes our CH2OH. I hope this is clear. So alpha D minus fructose, okay, alpha D minus fructose. Now the second way of representing. So if the attack taking place from this side of the carbon, okay, if the attack is taking place from this side of the carbon, then how it will be? So this will be H, then there is CH2OH, okay, the OH will be on this side then, okay, then will be C, then HO, the remaining will remain the same, okay, that is HOH, then CHOH, then CH, okay, and that will be like this 0 and CH2OH. So as this is on the left hand side, so this will be beta D minus fructose, as this is a levodotative. So this is a cyclic structure, okay. So this is a cyclic structure of your 5-membered ring, that is fructose. So next we are going to see the Hayward structure. So same way we can write the Hayward structure also for this Hayward structure. Okay, how do you write the Hayward structure? It is a 5-membered. Okay, so this Hayward structures of two anomers can be written as, so how many this is present, just see here now. So it will be 1, 2, 3, and 4. So it forms a 4-membered ring. Okay, it forms a 4-membered ring. So the structure will be like this. So this is a, okay. So I'll write the structures. First I'll write one structure here. So first I'll represent our alpha D okay, fructofuranose. So this will be, so this is on the left hand side, so it will be CH2OH. Then your OH will come on the right hand side. Here it will be OH and H. This will be HOH. This will be mm, this will be CH2OH and H. Okay, so this is a structure. So this is a structure of our furanose. 1, 2, 3, 4. Okay, sorry, one. Okay, you have to calculate from here. 1, 2, 3, 4, and 5. Okay, so it is a fruct. So this is a what? It is alpha D. fructose. Okay, and it is a few four-membered ring, so it is furanose. Okay, so next is O. So here what will be OH will come above, so this will be CH2OH. Then the other things will remain same OHH. This will be HOH. This will be CH2OH and H. So again 1, 2, 3, 4, 5 membered ring. So the name is what? The name is beta D minus. Okay, so it is beta D minus fructo furanose. Okay, I hope this is clear. Right. So this is the Hayward structure of fructose. Okay. So this is a Hayward structure. So we have seen two monosaccharide. Okay. We have seen glucose and fructose. Next, we are going to see what are disaccharides. Okay, what are disaccharides? So disaccharides are the condensation products of two monosaccharide units. Okay, the monosaccharide joined together by an oxide linkage, and this linkage is called as what? Glycosidic linkage. So we have seen just now one example of maltose. Maltose is also called as the malt sugar. It is called as what? It is called as malt sugar. The formula is C12 H22O11. Okay, so this is the structure of what you say uh, glucose. Okay, so we'll write the maltose, how it is obtained. Maltose, when two glucose units are linked. When two glucose units are linked, we obtain maltose. So just now we have seen that structure. Still, I'll write the structure again. Okay. Mm, so H O H. So HOH. Hmm. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is what? This alpha D glucose. This is also alpha D glucose, right? So the linkage is between what? So maltose, it is consist of two alpha D glucose units with the C1. Okay, from the C1 of one glucose, and it is linked to C4 of another glucose. Okay, so this is a reducing sugar. So this is an example of what? This is an example of a reducing sugar. What do you mean by reducing sugar? Which can reduce the filling solutions and tolerance reagent. Okay, because of free aldehyde group, there is a free aldehyde group. Okay, which is produced at C1 carbon of second unit of glucose in solution. So when you add this a solution, so in the second unit, the aldehyde group is free. Okay, so this is the what you can say. This is the second. So in disaccharides, so this is the first example which we have seen. Understood? So maltose. Okay. So next, second example which we are going to see is sucrose. Okay. The second example in the disaccharide is your sucrose. So what is the formula of sucrose? As we have seen, sucrose is called as the cane sugar. The formula is C12HO22 and that is sorry C12H22 C12H22O11. Okay, so how it is obtained? So how it is obtained? So sucrose, it is comprised of alpha D glucose. So how the structure is made up of alpha D glucose and beta D glucose. So when this so there are two units. So disaccharide means what? There are two. sugars, that is two units are joined up. So when it undergoes hydrolysis, it will obtain two monosaccharide units. So two monosaccharide units are alpha D glucose and beta D fructose. So the preparation is C12H22O11. When it undergoes acid hydrolysis, okay, it is obtained C6H12O6 plus C6H12O6. So this is a glucose and a fructose is octane. Okay, so these two monosaccharide units. So we'll write the structure first, then it will be more comfortable. Okay, so so the glucose we have seen the structure of, okay, glucose is a pyranose structure. So I'll write it. Okay, the pyranose structure. So this is HOH. Fine. Then here will be HOH. Then this will be OHH, and this will be HOH. This will be CH2 OH and H. Then our pyranose structure, sorry, that is your furanose structure. Fructose structure is like this. Okay, so here comes your OHH. This comes your HOH. Here comes your CH2 OH and H. And okay, this is your OH and CH2OH. So this is a beta D fructose, right? Beta means OH will be on the left hand side. Now the linkage, okay, how the linkage will be? Now these two, okay, here the HOH linkage. So HO, HO, and here, right? So this is our structure of glucose. I hope this is clear. Right, so this is our structure of fructose. Okay, so this is sucrose. So this is the structure of fructose. So this is the sucrose, right? So, so like this. So like this, the linkage is taking place, right? So these are the two monosaccharide units which are held by a glycosidic linkage. So what type of linkage is present? These two units make up, okay, by a glycosidic linkage between the C1 carbon. So this is a C1 carbon. So one, two, three, four, five. This is two, three, four, five. Two, three, four, five. Sorry, one, two, three, four. Okay, so this is a so it will be two, three, four. Okay, so here you can see that the glycosidic linkage when you are forming the sucrose structure, the glycosidic linkage is between the C1 of the alpha glucose and C2 of the beta fructose. So hence both this aldehydic and ketonic groups are not free. Okay. In this case, both are not free, the aldehydic group and ketonic group. Thus, it is an example of non-reducing sugar. Okay. It is an example of non-reducing sugar. So as there is no free aldehydic group. Okay. So this sucrose, remember, this is a dextrorotatory compound. This is a dextrorotatory, okay, and which on hydrolysis will give you dextrorotatory glucose and levorotatory fructose. Okay, so when sucrose undergoes what is that hydrolysis, it will undergo. It will form beta, that is alpha D glucose and beta D fructose. So your the fructose will be levorotatory and your glucose will be dextrorotatory. Okay, so therefore this is the thus the sucrose is a dextrorotatory. So this is our second disaccharide. Okay, so first we have seen is maltose. So maltose, then we have seen is sucrose. Okay, now we are going to see is the we are going to see next is lactose. So lactose is also a disaccharide. So what is lactose? Lactose is milk sugar. Okay, it is present in milk. Lactose is a milk sugar. What is the formula? C12H22O11. Okay, C12H22O11. So how it is made up of? It is made up of beta D galactose. Okay, beta D galactose and beta D glucose. Okay, beta D glucose. So I'll write the structure. So O. So this is a structure of your so beta D galactose and beta D glucose. So this is a structure. Yes, so this is a structure of our lactose sugar. That is, the lactose sugar is made up of two monosaccharide units. That is your beta D galactose and alpha D. Sorry, beta D galactose and beta D glucose. Okay, so you can see here the linkages between 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so here so it is made up of beta D galactose and beta D glucose. So the linkage is present between C1 of the galactose and C4 of the glucose. Okay, so remember this. Okay, so the structures are very important. So we'll stop for the day here. So what all will we have studied today? So just will revise. So we have started today with the structure elucidation of glucose, right? We have seen the different reactions for elucidating the structure of glucose, right? So we have come with the open state structure, right? Then we have seen the cyclic structure of glucose. Okay, then we have seen the Hayward structure of glucose. Then we have studied about the fructose. We have seen the hemiacetal structure as well as the Hayward structure of fructose, right? So in monosaccharide, we have studied two examples, monosaccharides. Okay, we have studied two sugars. First is the glucose, okay, and the second is the fructose, right? We have seen the fructose. Then disaccharides, okay, disaccharides, we have seen what are disaccharides. Then we have seen the examples. The first one which we have seen is maltose. We have seen the structure. Okay, we have seen the hemiacetal structure also. Second one which we saw was sucrose. So the hemiacetal structures and the not hemiacetal, the Hayward structures are very important. And the third one which we have seen is the lactose. Okay, maltose is malt sugar, sucrose is cane sugar, lactose is your milk sugar. So glucose, okay, grape sugar, right? So these are the names which you need to remember. Fine. So this we have studied in today's class. So remember that disaccharide units means it consists of two units. Okay. So for example, maltose. So what is it is made up of maltose? It is made up of alpha D glucose and alpha D glucose, two glucose units. The linkage is between the C1 and C2. Okay, it has a glycosidic linkage. Then sucrose, it has two monosaccharide unit, that is alpha D glucose and beta D fructose. The linkage is between the C1 of glucose and C2 of the fructose. So it has a C1 C2 glycosidic linkage. Then the third one is lactose. Lactose, it consists of beta D galactose and beta D glucose. Okay, the linkage is between the C1 and C4. Okay, that is C1 and C4 glycosidic linkage. I hope today's session is clear. So today we have discussed about okay the disaccharides. So okay, so in the next class we'll be studying about the polysaccharides. Okay, some of the examples, the structures of polysaccharides. Okay, and then we will study the further part. Okay. So thank you. I hope today's session is clear. So we'll end the class here. Okay. So we'll meet in the next class. Thank you.